Hello, everyone. Welcome to our webinar, Total Cost of Ownership of Cloud Big Compute versus On-Premise. My name is Mika Peggers. I'm a Product Marketing Manager here at Rescale, and I'll be your host for today's discussion on the Total Cost of Ownership, or TCO, of Cloud HPC. To help tell the story, we have Matt McKee, who's responsible for Rescale's business in North America, and Gabriel Brunner, our VP and GM of HPC here at Rescale, both presenting. They'll give us a presentation that contains a framework for asking the right questions about cost and ROI for you to use when thinking about whether cloud HPC makes sense for your organization. Before we get started, I'd like to go over a couple of housekeeping items. First off, we are recording this presentation and we'll be distributing the recording within a week. And secondly, if you have any questions during the webinar, please make sure to type them into the questions section in the GoToWebinar panel, and we'll address those at the end of the webinar. And it's better to do that earlier rather than later. Okay, Matt, if you're ready, let's get started.
Thanks, Mika. Good morning to those in North America, and good afternoon to our colleagues that are joining us from Europe. The team at Rescale is pleased to have everyone in attendance today to learn about this much discussed topic of total cost of ownership, often referred to today as TCO. Total cost of ownership is a subject of some of the more frequent questions we get at Rescale when talking to our customers about moving high-performance computing and compute-intensive workloads to the cloud. As a result, we thought it would be useful to summarize our thoughts and perspective on the topic, largely because simple answers are often incomplete. So here's the agenda for today. We'll do some brief introduction of this subject to provide some context. We'll discuss the limitations of using TCO to drive investment decisions. We'll discuss a framework for asking the right questions when making investment decisions. We'll address some case studies. Then we'll talk more generally about the evolution of the cloud, and then we'll summarize at the end. So what can we add to this topic? There has been a lot of thinking and writing done about the TCO of cloud computing. This list here is simply the results from the first 3 pages of Google search on the words TCO of cloud computing. So as you can see, there's a lot of information out there. So with all this thinking and writing on this topic, what can we add to this discussion? To answer, there's very little quality information in this space, particularly relevant to high performance computing. As a result, we can drive down to another level of detail on assessing the costs and value of HPC on the cloud. The term quote unquote cloud means something different to everyone. Amazon Web Services, for example, has 120 different services available, from security, identity, and compliance to mobile services to application services. Many of these articles listed here address cloud at a level that is good for context, but not immediately helpful for looking at HPC specifically. That is what we'll focus on today. Our intent today is to give everyone some key takeaways from the session. Sometimes it's helpful to start with what you won't get. And what you won't get today is how much it costs to run your on-premise system on the cloud. This is the wrong question, and we'll talk about why. Next, you won't get a detailed breakdown of fully loaded costs of on-premise computing. We'll certainly have some discussion on this, but frankly, a detailed analysis of this kind would be pretty boring to listen to. And there's a lot of resources out there to help you determine these costs. Next, you won't get pricing for all possible deployments of HPC workloads to the cloud. The mix of on-premise versus cloud will be different for everyone, so there's no boilerplate answer here. What you will get is you will get a framework to help your organization think about the issue and do its own analysis. We'll talk about how to ask the right questions, and we'll talk about how to assess costs, and more importantly, return on investment. Lastly, you'll get Rescale's perspective on where this whole cloud HPC thing is going. To get us started, Gabriel Brunner is going to provide a brief introduction. Gabriel is Rescale's VP and General Manager of HPC. Gabriel has spent more than 25 years in the industry, holding positions at Cray, Microsoft, Ericsson, and most recently, Vice President and General Manager of HPC at SGI, which was recently acquired by HP. Gabriel, all yours.
Thank you, Matt. I appreciate letting me give an intro to this topic that is dear to my heart, and thank you for the audience to be here. This picture here, high performance computing, reflects two things. For me, is a history of disruptions, but also is dear to me because it's a bit of the history of my life. I joined Cray in the 90s, and what you see on the left is the Cray 1 with Seymour Cray. And that's a machine that had a very special architecture that would cost perhaps $20 million to buy. That set a tone. When you have a high performance computing machine, I had to work on it because I was doing operating systems in the middle of the night when I have time available. But in general, you can think that a resource so precious would be put in a central room and be shared by many people. By being shared by many people, we had to come up with concepts of how we share the machine, how we schedule jobs, how you wait to use this unique machine. What happened at the time I joined Cray, we were thinking about massively parallel systems, and this machine, the second machine here, is a Cray T3E, and I was part of the design of the implementation of the operating system. At the time, this was a crazy idea. We're going to take what Cray had designed as these unique systems and turn them into commodity or standard processors with its own memory and dedicated interconnect. Well, the reality is over time, you've seen that HPC clusters have won the battle. What happens is the price performance of the cluster, if you're able to parallelize the application, ends up being better than buying a dedicated machine like that. So I consider that one big disruption. Then I was at SGI, and at SGI we proposed to run Linux as an operating system. Most customers initially said Linux is a toy operating system that'll never work. Eventually, after 2-3 tries, customers understood that with Linux they get availability of applications. We at SGI were able to have fewer people developing the OS, and the people developing the OS had the unique things they needed in HPC. This particular machine is the Columbia machine that we sold to NASA. It was the #1 machine in the world for a few years in 2004, and it's a machine that allowed them to send the shuttle back in space. Here to the right is the machine that NASA Ames has today, which is the Pleiades machine. And if you see the difference now is these machines are now 2 CPU nodes, basically an Intel architecture, and the difference between one vendor and another vendor ends up being mostly about packaging and cooling and not so much about the architecture. So over all these years, we have gone from a very dedicated machine to machines that are very standard with different types of packaging. In parallel, what has happened in the industry is, as of a few months ago, I was at an Intel event, and Intel said, as of that moment, they were selling more processors to the cloud than on premises. So incredible growth in the cloud in general, but not so much in HPC. In HPC, some analysts would say it's about 3% or something like that, or 5% of all of HPC happening in the cloud. Now, that doesn't mean that it's not happening in the cloud. It means it may be the beginning, but things need to change. So I personally view this HPC in the cloud as the next disruption in HPC. Just like in all these moments when we talk about either a cluster or Linux or standard nodes, our customers look at us like this is crazy. The fact that we talk about cloud now, that many customers look at us like it's crazy, is kind of an interesting point. It's a deja vu for me multiple times. So why is cloud interesting? If you think about why all these changes have won, it's because in the end, they offer better price performance for the application you need to run to the customer. And that's the interesting thing. Customer running simulations want to run simulations faster. When I talk to people, when I talk to customers that have simulation jobs to run, to design a car, for example, they like to see that they shorten the simulation cycles, they can do high resolution simulations, they can try more alternatives. And in order to do that, they want to have better price performance for the application. What happens when you go to the cloud is you open up new possibilities in a number of ways. Can you go to the next slide, Matt, for me? I wanted to talk about this other change that happened. Most of our customers at SGI will ask me a few questions. One is, Gabriel, what are your cloud plans? Another question they ask me is, with the new variety of architectures, what should I buy now? So in this case, you have on the left the types of processors. It used to be a world where application performance grew with the performance of CPUs. Now we got to a world where you have to decide between CPUs, GPUs, KNLs from Intel, FPGAs, etc., and multiple types of interconnects. So when you buy a system in-house, effectively, you're making a decision that is going to run for the next 3 to 5 years. You buy it into an architecture. Today, you may decide, I'm going to buy Intel Skylake with InfiniBand DDR. That's what I buy. Well, that's a system you're going to have for the next 3 to 5 years until the next procurement. All the jobs are going to run in that architecture. Well, that's a reality. The other thing that's going to happen is, because it ends up being sort of a unique resource, not only all the jobs run in that architecture, but you usually will have the system highly utilized. You're going to buy the system that will be highly utilized to amortize your investment. And what that means is you're going to have a job queue of jobs that need to run that will be executed later. So even if the machine is fast, the reality is you usually have a queue and you have to wait to run on. And the other thing is you're running on one architecture all the possible jobs. Can we go to the next slide? And this is what made me, after 25 years of HPC, come to Rescale, and I've been here 3 months now. What happens in the cloud is, first, you have instant access to unlimited resources. What means is, when I come to the cloud, I don't have to wait in a queue. I don't have to wait until I get a system provision for me to use. I can today or tomorrow say, I need 1,000 CPUs to run this big job I need to run, and I just get them in the cloud. I have a choice of architectures. So for example, if one application, like some cases Abacus, runs better on GPUs, or deep learning runs better on GPUs, but LS-DYNA runs better on CPUs with InfiniBand, then what I can do is, for each application, I can run it on a different architecture. That means that I won't have to decide up front what architecture to buy and be committed to it. Because if I split my machine, half CPU, half GPUs, I'm also committing to having to have, half full on one side and half full on the other side. That's pretty hard. That doesn't happen. And having 3 CPUs that don't help me if I need GPUs. So applications in the cloud, at least on the Rescale cloud, they run on the best suited architecture, and jobs run with no wait, because I can always start a job right away in the cloud. The engineers are not constrained by the size of a system. Another thing I hear from my customers is, when somebody shows up with a big job, I'll ask them, how often you're going to run that job. The reality is they're not gonna know. They want to try this big model. If this works, they may come up with a new innovation, but they cannot do it on a fixed size system. So what this leads to is faster innovation. If I have access to the CPUs I need when I need, I can do faster innovation. I can do shorter design cycles. Our company was founded by 2 wing designers at Boeing that ended up over a weekend getting 1,000 CPUs and running the wing design of the 787 totally in the cloud. And that's very, very interesting, because that led to a design done in a weekend that otherwise it'd have taken pretty much 3 months to complete. And that's what leads to improved time to market. Our customers like SpaceX, what they do is they have to do like 100,000 simulations before they launch a rocket. By using the cloud, they can do it very quickly, instead of waiting for a big system, for a system in-house to do it that will take them months. So that's a reason for cloud. So you get immediate provision, you get variable size. And another question I had for my customers is, in the next round, they don't want to buy a big system, they don't want to have a big capital investment, or their management is asking them not to have a big capital investment. So some things that go away, system utilization, something that you measure in systems in-house, but you don't in systems in the cloud, in running in the cloud. Job queues don't exist anymore, so you don't need a scheduler. You simply go to the cloud and run your jobs. Downtimes that you have in-house are also not needed, because in-house you need to do downtimes for maintenance or upgrades. Those become a thing of the past. So what I would say with this is, when you run in the cloud, you have a number of benefits. The question that you'll ask yourself is, okay, but cloud is more expensive than on-premises, and that's a question I get all the time. If I add a CPU to the cloud and I compare adding that CPU to my on-premise system, is it going to cost me more? And the reality is, I believe that's a wrong question. The right question is, I have a workload that I need to run, because in my company, I have a workload with peaks and valleys I need to run. If I buy a system in-house and I need to run everything in that system, in that one architecture, how much is it going to cost me? And what kind of results am I going to get? what's the service I'm going to get, what's the time to simulation I'm going to get for all of my jobs. Now I make that comparison using the cloud, where I have the possibility to run on the best architecture for the job, where I can run the applications that need high performance interconnected, high performance processors to run that way, and the applications that don't need it to simply go back and run on an older version of the CPU. When you do that math, we see that our customers are typically spending less per month than they would have if they had bought the equivalent system in-house, and they're getting better service. So that analysis really motivated me as I started looking at HPC in the cloud. So why do I think it's the next disruption? Because like commodity processors end up costing less but giving you overall better application performance. The reality is now cloud is costing the same or less but giving you much better results. So I think it's right what Matt shared earlier, talk about ROI, TCO. To me, is ROI because you're working in the core business of the customers when you do HPC. So if you offer them a solution that they're able to do simulation much faster in the cloud, the customers will be able to take that by spending the same amount of money or less. So that is a quite interesting topic. I'm very passionate about it. I'm going to turn it over to Matt. I want to give that intro, which is basically the story of my life of 25 years and 3 months. And now I let Matt go through the analysis, which I think will enlighten us a bit. So thank you, Matt, for letting me do the forward here.
Thanks, Gabriel. And we'll dive into some more depth on many of the points that Gabriel just covered. So to reintroduce myself, I'm Matt McKee, and my role at Rescale is the responsibility for our customers in our business in North America. Before joining Rescale, I worked in an engineering software company and at Accenture doing consulting for IT organizations. So to begin, I wanted to get a few things out of the way that seem to weigh heavily on the industry's mind as they wrap their head around an approach to the cloud. First, the right mix of on-premise and cloud HPC is different for every organization. Some organizations can fully detach from constrained assets, while others may need to take a longer journey to get there. Others will pursue a hybrid solution. Second, incorporating cloud HPC is not always a pure cost savings play. Sometimes the end result is a larger return on investment, not lower total cost of ownership. And sometimes it's both. It's about the business case, and we'll explore this more later. So total cost of ownership is an analysis that seeks to quantify the many facets of direct and indirect costs related to a product or service. At its root, it's a managerial accounting tool, and its popularity has grown in the last 20 years as specifically IT organizations seek out areas to reduce expenses and overhead. For example, doing good TCO is credited for Gartner's revelation that the lifetime cost of a personal computer is 5 times its purchase price. Also bolstering TCO's popularity, it's relatively straightforward. And really, our human psychology is simply more wired up for loss aversion. In other words, to think about what we're losing than for what is gained. However, the problem is that TCO in its cost-oriented analysis becomes a substitute for the more relevant but more analytically challenging end-to-end analysis of value. I'll make the argument that total cost of ownership is an inherently static approach to assessing the costs and benefits of on-premise and cloud computing. It's static because it tries to compare a static constrained asset with a dynamic unconstrained environment. As a result, it can be at best incomplete and at worst misleading when making investment decisions for your organization. This is often where TCO analysis of an on-premise HPC versus the cloud HPC begins. Someone asks the question, how much does it cost to run my on-premise system in the cloud? It's a very natural place to start, especially when an organization has years of doing something a certain way. The cost element is this large compute clusters, and budgeting and purchasing have been built within this box or way of thinking for sometimes up to 30 years. It's the on-premise zeitgeist, and it's a comfortable place to start. However, this is the wrong question to ask. At the root of the question, it's asking, how much does it cost to move a constrained asset to another hosting location? And that is not what moving to the cloud is about. We commonly refer to this type of TCO approach as the lift and shift TCO. As described previously, it looks like this. I have 5,000 cores of compute. How much does it cost to run that in the cloud? And to that end, the cost comparison seems simple. On the left, I will take the cost of 5,000 cores of my on-premise hardware, I'll add in my software costs, and I'll add in operational costs. Then I'll ensure that's matched up with my 3 or 5 year depreciation schedule, and I'll get an overall cost X. Then I'll go to my accessible cloud computing contact and I'll ask them for the following information. Give me the cost of running 5,000 cores 24/7 for a year. What are my data transfer or storage costs for some X amount of data? Then I'll put an estimate on the type of software environment or development effort I need to support it all. Then I'll come up with a number. Multiply that by number of years that line up with my depreciation schedule, then I have my number Y. In this situation, I've lifted and shifted my same constrained asset to the cloud, and now I want to know if I save money. For some companies building up HPC from scratch, they find this to be true. The cloud can save them money. For other companies with large HPC footprints, looking at incremental costs, they can be disappointed in the comparison of X and Y. However, they shouldn't be. While the intent of this lift and shift TCO was to be an apples to apples comparison, it's not in practice. And as a result, the comparison was built to fail from the beginning. To help start to explain why, it's sometimes helpful to start back at the beginning, from the requirements up. So take this organization with a variety of demands for compute, 5 different groups with 5 different average usage levels. If you're a user somewhere in this organization, the optimal position for you is have your own private HPC under your desk. This way you have resources you need when you need it. It might even be optimal for your small group to have their own HPC, but organizations do not have the resources to do this. And having an HPC as a personal resource is ridiculous. So how does an organization satisfy these diverse requirements? What has happened for 30+ years is an organizational compromise. They select a static resource, pool users and workloads, and press forward. And for all these years, this was basically the only choice. It was that or continue to collect capitalized assets. Today, this type of compromise isn't necessary. So to finish this thought out, 2 key points. First, a TCO analysis is not a business case and shouldn't be substituted for one. It's incomplete and misleading to simply look at TCO. Second, when doing a lift and shift TCO, it's trying to fit a static paradigm into a dynamic one, and it just doesn't fit. We'll discuss next how to use a dynamic framework for making investment decisions. The framework we'll discuss is about asking the right question. It has 3 parts. First, assessing the current state. Second, defining service and capability levels. And third, identifying business value. The first step is assessing the current state. This is a snapshot in time look. What do things look like right now, today? This is a combination of looking at hard cost, soft costs, and usage patterns. So the first question to ask is, do we have a complete understanding of our full cost picture? The easiest part is the hard cost assessment, but even those can have some cost elements that elude some. Here is a listing of operational expenses, several of which that are often overlooked. These detailed costs are one of the areas that has been covered quite extensively in resources that are publicly available all across the internet. I've read some especially detailed and comprehensive lists that I can share, and we'll address some of those resources at the end. A question has come up is, why is something like planned outages on there? In short, any downtime or dip below 100% utilization is a loss in the system where most costs are fixed. This can either be represented as a cost or as a loss in value. The next question is, what are our hidden business and opportunity costs? Some opportunity costs are easy to uncover. When I spend $4 million on a capitalized asset today, I tie that money up in that asset until its retirement. Therefore, I can't use that money somewhere else. Some of the draw to cloud computing has been around this avoidance of capital expenses and shift to more nimble operational expense. but hidden costs can exist in other places that don't come to mind immediately. One that we hear often from researchers and engineers is a certain psychology that develops, a thinking inside the box kind of approach to problems. This will occur over time when resources are constrained and there's not a flexible way to extend those resources. There may be new methods, new designs, and new ideas within the organization, but a mentality can develop where people within an organization just say, it's not worth it. It'll take too long, I can't iterate on it, so let's just stick with the way we've always been doing things inside of our box. A pithy way to describe this is inside the cluster thinking. Here's another example of hidden costs, this coming from an article in the Harvard Business Review. The article was called The 6 Myths of Product Development and said this about creating any type of queue, whether project or resource. Queues delay feedback, causing developers to follow unproductive paths longer. Queues make it hard to adjust as the market changes and evolves. And queues have economic costs that most companies do not calculate. The next question is, what would our peak workloads look like in an unconstrained environment? It can be difficult to unravel this data, especially when an organization is running at a very high utilization level. However, it is possible, and as an example, Rescale has developed a small data analysis tool to calculate the productivity loss in the system due to queuing. So the next step is to define the service and capability levels desired. This can be difficult because there are competing demands and misaligned incentives within an organization. On one side, organizations are incentivized to maintain high utilization, high return on assets, predictable CapEx, and low budget variance. On the other side, the organization wants the fastest speed to answer, the right resource at the right size in the right time, flexibility to scale up and scale down without consequence, and reduced administration, particularly breaking the cycle of writing up a business justification for procurement every time requirements evolve. Setting the service and capability levels look different for every single organization. Many organizations want to be able to satisfy peak demand, but think it's cost prohibitive to do so. For deciding between on-premise and the cloud, this can be the most critical question for your organization. We at Rescale can confidently say that incorporating the cloud into your HPC environment allows organization to achieve the highest service levels at the lowest cost. And the last step is to determine business value. Those simply looking at TCO never get this far, and that's unfortunate because that's where the real business cases are made. The first question to ask in this last step is, how does our organization value agility? We've talked a lot about driving flexibility back into the organization. Agility is the ability to react when the market evolves and requirements change. This means changing user usage patterns faster than the capital budget can keep up, but it also means changing systems or architectures in the click of a button. I will quote Dr. Christoph Grote, the leader of BMW's Advanced Technologies Group, who said, "It's going to be the agile that will end up the winner." And there's not a nice, clean number to put around this value, and it will look different for every organization, as I stated earlier. One Fortune 100 company we work with shared that in their on-premise paradigm, it took them 12 to 18 months to react to a new requirement, and this was simply unacceptable to their user community. The next question is, how do we value our engineers, researchers, and data scientists' time? But in terms of value, what this question is really asking is, how do we value faster innovation cycles or reduce time to market? For some industries, cost is secondary to speed. Queues and constrained resources are antithetical to speed to answer, especially when iteration and fast failure is critical to the process. And the last question gets back to a comment I made earlier about inside the cluster thinking. The question is the flip side to what hidden costs are you incurring when a research team determines that it would simply take too long to explore a range of cases that could optimize a process. The question is, how would approaches to problems change in an unconstrained environment? And in terms of value, how would your organization derive a benefit from these new approaches? One of the reactions I sometimes get to this question is, if I let my users run loose, they'll waste our time and money. There are even organizations that use on-premise clusters as a tool to constrain their user base purposefully. In these cases, this is a management problem dressed up as an IT problem. Incorporating the cloud does not mean unconstrained cost and is not a shortcut around fiscally responsible behavior. So in summary, the framework has three distinct parts to it: challenging the organization to think about how business is being done today, the service and capabilities levels it wants to provide, and the business value of changing the paradigm from static to dynamic. So we've covered the framework to help understand the true costs and the value that cloud HPC can bring, but we haven't really looked into much of the cost of the cloud. At some point, we need to put a number down on how much all this value is going to cost. So we'll spend some time on that topic right now. The costs for cloud HPC fall into two distinct buckets: those charged by the infrastructure as a service provider and those costs the organization bears to provision the cloud. Infrastructure as a service providers range from the market leaders, such as Amazon Web Services, Microsoft Azure, Google Cloud Platform, to supercomputing centers and bare metal providers. These providers have two basic costs for cloud HPC: compute, typically charged by the core or the node over some time domain, and storage, typically charged by the terabyte for holding or transferring that data out. This is where the costs for the infrastructure providers stop. For those keeping score, we discussed a lot of often overlooked or hidden costs for on-premise HPC. So you may be wondering if cloud HPC has any costs that are typically overlooked. The answer is yes. In the realm of cloud HPC, they fall into this second bucket, which is the cost an organization bears to provision the cloud. For example, all infrastructure as a service providers have a shared responsibility model for security and compliance. This implies that organizations have to take certain actions to ensure security and compliance on their end. An example of this is an infrastructure provider is not going to encrypt server-side or client-side data and network traffic on behalf of its customers. Into the organizational responsibility bucket, these items fall: shared security and compliance mechanisms, systems administration, which includes software license management, installation, configuration, and testing of a suite of tools, organizational level management and monitoring mechanisms, productivity and workflow tools, overall deployability and user experience, and several other components. In short, there are software tools and systems integration work there that represent a cost. Eliminating these costs through an elegant platform that brings together best architecture, hundreds of applications, and users is what Rescale does. So let's now discuss two case studies of Rescale customers that illustrate some points I made earlier. Both companies are large companies in the automotive industry with revenues in excess of 1 billion. Both are global companies, diverse range of requirements, and have on-premise HPC capabilities already. The first case study will address the question, what service levels do I want to provide? And the second case study addresses the question, how would our approach to problems change in an unconstrained environment? This tier 1 automotive supplier was wrestling with how to satisfy peak workloads and control their costs. In fact, this was their usage pattern, and it's the same one I used earlier to illustrate my point about understanding peak workloads. If they bought a system that accommodated the peak workload, they may have to spend around $20 million, but the system will only be 20% utilized. If they bought a $4 million system, the system will be highly utilized, but large jobs cannot be run and jobs will wait in the queue, potentially for days before they run, delaying innovation and time to market. This organization decided that neither option was acceptable to them, and they instead decided to go with Rescale and run HPC in the cloud. They now pay between $50,000 and $100,000 per month for the IT they need when they need it, and they have instant access to a perfectly sized system without waiting, significantly improving design throughput and time to market. With the Rescale cloud platform, they get the best of both worlds. They spend monthly what they would have spent in depreciation of a $4 million system, while they get the service of a $20 million system. Our second case is with a company that was considering a novel technology and developed a method for a computational fluid dynamics design study. This method was critical to the product's development, but a design study of this type had never been possible in the company. In their current HPC environment, they estimated that the design study, which would have to occur on a cyclic basis, would take 80 days to complete. The R&D team needed it done in a day. The additional CapEx required to satisfy the R&D team's demand was estimated at $3.8 million, but in the cloud, it was $1.9 million. The team estimated the potential revenues from this product to be approximately $1 billion, and the engineering costs were estimated at $100 million. However, this design study was estimated to save between $2 and $5 million in engineering costs. Only approach in the cloud could justify their conservative estimate here. Furthermore, this was the R&D team, and all their requirements today won't be their requirements a year from now. And tying that money up into an asset with a 3 to 5 year lifespan simply did not align with their innovation cycles. So where is the cloud going for high performance computing? In some ways, we're just getting started. HPC workloads are moving to the cloud at an accelerated pace, and organizations that 3 years ago claimed that the cloud wasn't for them are jumping into the pool. In 2016, Accenture did a C-level survey about cloud initiatives, and 95% of companies are reported to have a 5-year cloud strategy. 89% of C-level executives agreed that implementing cloud strategies was a competitive advantage, and 80% believe that public cloud security is more robust and transparent than what they are able to provide in-house. As CIO consultant Tim Crawford said recently, the question is no longer why cloud, but how cloud. This massive movement will not bypass HPC. There is a fundamental shift of investment moving to the cloud. Companies built on on-premise licensing and infrastructure have seen declines in reorganizations, while the major cloud providers are investing heavily and growing even faster. Amazon Web Services is growing at 80% and has emerged as a cloud market leader. Microsoft and Google are quickly closing the gap on AWS's market leadership. And all three players have turned their attention to high performance computing and are driving significant investment there. In addition to these players, there are bare metal capabilities emerging across the market. Hypergrowth and hyper competition in the industry is going to drive value back to customers. What this means is that performance will continue to improve, costs will continue to go down, and migrations will continue to get easier, all driving value back to customers in the market. So, with all that said, where does Rescale fit into this? We couldn't get away with just a small plug about what Rescale is all about. And in short, Rescale is HPC in the cloud. Rescale provides the ability for organization to capture all of the value we discussed in the framework in the most efficient and cost-effective manner. Rescale's cloud platform, built on a bedrock of industry-leading security, allows organizations to leverage the best of the cloud through a single intuitive user interface. Rescale is partnered with the best data centers in the world and continues to expand to provide the best mix of capability, availability, and value across the various workloads we support. Rescale is a single platform that supports an entire organization's HPC environment, from commercial to open source to proprietary applications. Furthermore, Rescale enables organizations to take advantage of on-demand and elastic licensing from software companies that support it. So where can you find more information? As I alluded to earlier, don't just take Rescale's word for it. There's a lot of information out there to find. And here are some sources that I recommend based on the quality of the information that they put out. Many will recognize Gartner and Forrester. I've seen some particularly compelling articles recently from McKinsey, who's been writing a lot about infrastructure and operations in information technology. Accenture has been a major player in advising information technology organizations for many years. And a particular thought leader that was named one of the top 10 thought leaders in the cloud is Brunner. He has a blog and he has a site. He has a lot of interesting articles there to read. In addition to that, as I mentioned earlier, there's a lot of thinking out there across the internet. Simply a Google search for something like the TCO of cloud reveals a range of articles to sift through. Now, some are better than others, and you're kind of going out into the public domain, and there's going to be a range of quality there. But at the same time, it's good to read a lot of different perspectives. As I mentioned, in doing some thorough research for this webinar today, I read about 30 different articles of varying quality, some of which I would recommend to others to read. And there's been some really quality studies and really quality analyses about the hidden costs of on-premise and all of the different facets of thinking about it, how to value agility and flexibility when moving to the cloud. And one thing that you'll see often is that a title of a lot of these articles will be something like the elusive TCO of cloud computing. And this is for all the reasons that we talked about, because not everything is very easily concrete and put into a number. And when doing TCO, you get very focused on what is that number. But if you take away anything from today, use that framework to assess the larger end-to-end value of what kind of results you're trying to drive back to your organization. I hope that was helpful today. That is the completion of that. I think that we might have some questions, but again, I hope this was helpful. The discussion will continue. Please feel free to reach out to Rescale at any time. If you have questions, you can reach out to me directly. My email is matt@rescale.com. This will be posted on the Rescale site for watching later. And if you want to be able to pull this framework, I'm also happy to provide kind of a truncated version of this where it's simply just some of the questions and some of the ways our customers have driven value out of incorporating cloud HPC into their environment. So Mika, I'll turn it back over to you.
Okay, thanks, Matt. Okay, so we're all out of time. So once again, thank you all for attending, and we'll see you next time. Goodbye.